Hello guys, welcome back. In this video, let us see one more scaling type. I hope you watched the previous video. There we have seen classic resize and elastic resize. Now in this video, let us see one more scaling option, that is concurrency scaling. So what is this type of scaling, sir? It just temporarily add more compute power on demand to process your queries. What it will do? It will temporarily add more compute power on demand to your queries. So what does it indicate? What does this statement indicates? Whenever you have a demand of your queries, whenever you are having a lot of demand of your queries, that is, when do you get lot of queries? When do you get a lot of demand on your queries? Whenever you are having a lot of traffic, then you got lot of demand on your queries, right? Yes. So at that time, at that moment of time, what this concurrent scaling is do? It will provide you temporarily more compute power. What it will provide you, this concurrent scaling, it provide you temporarily more compute power whenever you're having a on demand on your queries. So at that time, this concurrent scaling is used. So now let's see, we already have two types of scalings. What is that? Resize, classic resize scaling and elastic resize scaling. So let's remember these two as in the form of resize scaling. So we have already two resize scaling options we have. Then why I need to prefer this concurrency scaling? Actually, why we need to prefer is, so before that, let's see the variation between this resize, cluster resize and concurrency scaling. So in cluster resize, what happens? In cluster resize, what happens? When do we use this cluster resize? This cluster resize is typically used for permanent scaling of your Redshift clusters. So when do I use this cluster scaling? Whenever we want permanent scaling. If we want, we want, or else you can say this cluster resize will provide permanent scaling, will provide permanent permanent scaling of Redshift clusters. So it provide permanent scaling of your Redshift clusters. So whenever you need to adjust your capacity of your clusters for long time, for long time, or else you can say for long period. In technically, we can say for long period. Whenever you want to resize your cluster for long period, then you can use this cluster resize. If you want temporary resize, then use concurrency scaling. If you want to provide permanent scaling, then use this cluster resize. If you want to provide temporary scaling, then use this concurrency scaling. Whereas in this cluster resize, what it will provide is you can able to change the type. What you can able to do? You can even able to change the cluster type in this cluster resize. This cluster resize, what are the options do I have? I can even select what is the instance type, right? Yes. So in cluster resize, what are the options that you can have ability to select? Node type. Node type you can able to change, and number of nodes, right? Number of nodes also you can able to change. So these two you can able to change in the cluster resize. You can able to change new node type and new number of nodes. For what? For newly creating cluster. For newly creating cluster, if you want, then you can able to change the node type and number of nodes. Whereas in concurrency scaling, you don't even need, because it will be typically adding you compute resources. Like you can assume it like so it automatically provides you compute services inside your cluster. That means it automatically creates nodes inside your cluster. So when do this cluster resize is suitable? For long period. That means this cluster resize is more sustainable, more useful for sustainable operations, which are used for long term to complete, right? Yeah. So in which scenarios this is useful, cluster resize? This is useful when you want to maintain and adjust capacity constantly. So use case of this cluster resize is whenever or where you want to maintain the adjusted capacity constantly. Then you choose this cluster resize. So, so when do we want to maintain like this? When do we want to maintain the adjusted capacity? Whenever I'm having a lot of data in my Redshift, still I want to put some more data in my Redshift cluster. So in that case, do I need permanent storage for it? Of course. So during that scenarios, you can able to use this cluster resize. Why? Because it can able to provide, it can available for long period of time, and even it's a permanent scaling. It does not disappear like a concurrent scaling, right? Yeah. So here, if you want to change the node type, then you can even able to change the node type and number of nodes in your cluster. That those also you can able to configure under the cluster resize. So let's see the comparison to this concurrent scaling with this cluster resize. What are the points that we discussed? Let me write here. Concurrency scaling. So when do we use it? For so related to cluster resize, when do we use cluster resize? For permanent scaling. Whereas this concurrent resize, when do we use? For temporary capacity. For temporary capacity. So what type of capacity does it provide? Read replicas. It provides capacity of read replicas. Now, cluster resize, for how much duration we want it? Mm, For how much duration this cluster resize will support? For long period. Whereas this concurrency scaling provides you short term. That is, during your peak hours, it will scale up. During your less traffic, it will scale down. Right? Yeah. So when cluster experiences spikes in query, concurrency scaling provides additional resources. So when cluster experiences spikes, when cluster experiences spikes in query concurrency, then what happens? Concurrency scaling provides you additional resources. Concurrency scaling provides you what this concurrency scaling will provide you. It provides you additional resources. Right? Yeah. So coming to this, here we can able to change node type and number of nodes. But here we don't even need to change the node type because there is a no need, because temporarily it will provide me how much capacity we want, that much capacity. But here number of nodes will be number of nodes. There will be a limitation here. Number of nodes will be in between 1 to 10 only. 1 to 10, 1 to 10 clusters only you can able to create. So you can create up to 10 clusters in this concurrency scaling. So when do we use this concurrency scaling? For temporary spikes based on demand. If you got some temporary spikes during that scenario, this concurrency scaling is highly preferred. That means number of users who are reading the data inside your cluster are increased temporarily, who are using your database data very frequently. In that case, this concurrency scaling is highly preferred because those users will come only these days. Like you can assume, like under season days, most of the users will log into either any one of the shopping portal, right? And to got some items. So during those festival days, what those websites require, they need to provide a high spikes of their capacity, right? Yeah. So how they provide that spikes of capacity under backend by for database, since they are accessing, we need to verify, website need to verify every time their credentials. How website need to access their credentials? Their credentials will be saved under your database only. Let's say it will be Redshift. Now how they access it? Whenever they are coming and logging in, the request will go back to your database. That is nothing but your Redshift. So during that time, this Redshift need to provide whatever the data which is in it. So each and every time whenever a user logins, then it provides the data, right? Yes. So even the data which is present under your portal, which will be updated based on current demand and sales. So based on that, it will be updating, right? Yeah. So where those data will be saved, that also saved under database. So for those changes, immediately replicate under your databases, and that data will be replicated under your website. So number of requests that you are going to perform on your database will be increasing. So during those days, like you can say under festival days, your same cluster will become a superhero by taking this concurrency scaling. Since this, since this concurrency scaling will provide you a more compute power based on demand provided by the queries. So it will provide you how much amount of compute power that you require, that much. So like that, your single cluster can able to get a superman power, and it can able to provide responses to all the clients during those days, right? Yes, for that scenario, for temporarily during that festival days only we need that much of response. After that, the response will be normal, right? So for normal cases, you want to scale your cluster, then use this cluster resize options. We have two options based on your need. You can choose any one of them. Whereas for temporary scaling, for temporary capacity scaling, you choose this concurrency scaling. So I hope you understood this. When do we use this concurrency scaling? So let's move, let's move insights of this concurrency scaling. Let's move into this concurrency scaling much more. When do we use this concurrency scaling, sir? To provide capacity to Redshift cluster. AWS added which feature, which option under this Redshift concurrency scaling to provide capacity to Redshift cluster. AWS added concurrency scaling option under properties. Okay. how AWS is providing by this concurrent scaling, how AWS is providing the compute power by using this concurrent scaling. So by using this concurrent scaling, it will provide by using adds query processing power to cluster. What it will do, it adds query processing. It adds query processing power to a cluster. To a cluster. To specific users also. You can even able to specify particular users or only for particular users. You can provide this concurrency. Like that you can able to specify. Or you can even specify queues as needed. So if you want to provide this concurrent scaling for particular users, then it provides you a facility to specify that. And even you can provide queues for this. You can provide this concurrency scaling for separate queues as well, right? Yeah. So when do we need it? For handling spikes in querying concurrency. So handling spikes in query concurrency, we use this concurrency scaling. So how much time it will take, sir? It will set up in few seconds. It will set up in few seconds. Sometimes it may take hardly 10 to 15 minutes. So sometimes it may take hardly 10 to 15 minutes, but most cases it will set up under few seconds. So what is the efficiency of it, sir? So for how many concurrent queries or users does this concurrently provide the responses? It can, that is this concurrency scaling can efficiently handle thousands up to thousands of queries or users requests. You can say queries is nothing but users requests, right? So up to thousands of users, or you can say queries, up to thousands of concurrent users or queries, where this can able to, where this concurrency scaling can able to provide the response. So even these temporary read replicas are automatically deleted whenever you do not use this, or else whenever no need to use those. Whenever you are having a lot of clusters and your concurrency resources available, those also will be terminated back. That means those also will be automatically deleted. Whatever the read replicas, this will create a temporary capacity, right? Yeah, temporary capacity. So whatever the temporary capacity which was created by this concurrency scaling will be automatically removed, or else you can say deleted. Automatically deleted, automatically removes or deletes temporary capacity whenever it faces less, whenever it faces, whenever cluster faces less traffic, right? So during less traffic moments, it will automatically remove or deletes your temporary capacity, right? Yeah. Here you can see your main cluster will look like this. So whenever you enable this concurrent scaling, what happens is it creates additional concurrent scaling clusters. What it will create? It creates additional concurrent scaling clusters. Concurrent scaling clusters. So if you enable it, it will create concurrent scaling clusters aside to this. What are the Redshift cluster you have? Under that, main cluster will be present in the same way. But in addition to that, based on your need, it will create concurrent scaling clusters. Where these clusters, it create clusters from 0 to 10, in between 0 to 10. So based on your requirement, it will scale between 0 cluster to 10 clusters. So what does each cluster will contain? It will provide you some compute resource, right? Yeah. So it will provide you some capacity. That is read replicas it will provide you, right? Yeah. So hardly by default, the limit will be 0 to 10 only. Whereas 0 to 10 only. The hard limit for this is 0 to 10 only. If you want to create more concurrent scaling clusters, then you need to request AWS. If you want more clusters required, then request AWS. So that AWS will increase the number of clusters. AWS will increase the number of clusters that you can able to create for this. Number of concurrent clusters that you can able to create for this. So this is how the clusters will be, concurrent clusters will be scaled. So in order to scale from 0 to 10, first you need to specify the concurrency scaling parameter, that is max concurrent scaling parameter. Whatever the number that you select, up to that only it will scale. Up to that number only it will scale. It does not scale directly from 0 to 10. It scale up to max concurrency cluster value that you provided. You can see under cluster resize, what happens is under classic resize, the write operation is not performed while resizing is happening, right? Yeah. So whereas in concurrency scaling clusters, concurrently scaling clusters, it supports even write operations. Whenever your cluster is scaling also, it supports write operations also. We can even able to specify or configure which query will send at first to your concurrent cluster and which query will wait for their turn. You can even able to specify this under your Redshift concurrency scaling. So when you submitted a query, what happens? Redshift will plan, that is nothing but whatever the master node that you have, what are the leader node that you have, what does it create? It creates an execution plan, right? So this plan even contains how much capacity is required, even provided in this execution plan. So based on the required capacity, also, your data will be sent to clusters. Sometimes based on the capacity also, your data will be sent to the cluster. Since we are learning about this concurrency scaling, we need to know about SQA. So what is this SQA? Short query acceleration. In this short query acceleration, what happens? Your query is not directly distributed to your clusters. What are the scaled clusters? What happens is there is a ML model which is present in between. First, all your queries will reach to this ML model at first. Then this ML model, what it will do is, it will predict whatever the short execution time required queries. So this ML model will predict all the queries which will execute in short period of time, then all those queries will send to one cluster. All those queries, all the short time required to execute queries will send to one cluster. So there, all your short time required execution queries will run fastly there. So you can say you have avoided one problem, that is you have avoided for waiting for the long term execution query. You avoided the problem before executing the short term execution queries. You avoided the problem of waiting for these short term execution queries by using this SQA, right? Short query acceleration. So this will be used for that. So let's see from console how do we can enable this concurrency scaling clusters. So before enabling this concurrency scaling, first we need to note one point, that is max concurrency scaling set. We need to set this max concurrency scaling clusters. So we need to, in order to scale concurrently, we need to provide max concurrency scaling clusters, right? So number of clusters that this concurrency scaling will happen, that we need to provide, right? Yes. So first we need to specify this. So where we can specify this, sir? In AWS, we have an option called parameter group. What is that? Parameter group. Parameter group. So in this parameter group, you have to specify what you have to specify. You have to specify max concurrency scaling. Max concurrency scaling clusters. So that you need to specify under this parameter group. Under this parameter group, you need to specify max concurrency scaling parameter. After that, what you did is you attach this to where? So first you create a parameter group. There you need to provide this max concurrency scaling clusters value. Then you need to attach it to where? Then you need to attach it to what are the Redshift cluster. What are the Redshift cluster that you have? What are the main Redshift cluster that you have? For that, what you need to do? You need to attach this parameter group for it. So by default, a default parameter group is attached to this Redshift cluster. Now you have to attach this parameter group to this Redshift cluster, because you can, sir, can I able to modify this max concurrency scaling clusters in default parameter group? It is not possible. So that's why you need to create another parameter group, and you need to provide this max concurrency scaling clusters and then attach that to where? Redshift, your Redshift that you need to attach after that. So then you have an option called enable what? Concurrency scaling. Concurrency scaling. So under this cluster, you have a property called concurrency scaling that you have to enable it. You have a property called enable concurrency scaling, then that you need to enable it. So even we can see this from console. So before going to that, I'd like to provide you this, because it will be very to enable this concurrency scaling on lab by using this theory. So let's move on with lab. So at first, what we need to create? We need to create a parameter group and we need to provide this max concurrency scaling. So let's do that at first. So in order to create a parameter group, first you need to open your Redshift dashboard. It will look like this. So here you can see configuration, CONFIG, config. You can see the full form configurations. So here you can see workload management, right? Yes. So just click on it so that you can able to get the parameter group. Now I'm clicking on this workload management. So let's see to which page you will be redirected. After clicking on that, you can see the under the workload management, the parameter groups. So we have already what a default Redshift parameter group. So this default Redshift parameter group, we cannot even able to edit it. So because even it is attached to the Redshift, right? Yeah. So that's why we cannot able to edit this. So that's why click on create so that it will create a new parameter group. Just click on create so that your dashboard redirects to next page. Now I'm clicking on create. Let's see to which page it was redirecting. You can see you get to redirected to this page. Here you can able to provide a identifier for your parameter group. This identifier is nothing but a name where you can able to identify your parameter group. So provide the name and description, whatever the description you want, and then click on create. So now for current scenario, I want to provide here. I have just provided Redshift PG and my description like parameter group to be enabled to enable concurrency scaling. So like this, I provided some random description and some random name. You can even provide based on your requirement. Now I will click on create. So after clicking this, you will be redirected. Actually, while explaining, we have enabled this option at Redshift cluster, but we'll enable this concurrency scaling under the parameter group only. After creating the parameter group, then you need to enable this concurrency scaling. After enabling only, you can able to provide this max concurrency scaling cluster. So first we created our parameter group. Now, now we want to enable this concurrency scaling for this parameter group and provide this max concurrency scaling clusters for this parameter group. And just we need to attach this to whatever the Redshift cluster that is available. So let's move on with our lab. So what have we done? We just created the parameter group. Now let's see how to enable this property, that is concurrency scaling property. To enable this concurrency scaling option, so after creating your parameter group, you can see two parameter groups here. So just click on it so that you can see parameters and workload management. Under this workload management, you can see workload queues. So for this, just aside, you can see edit workload queues. Just click on it so that there is an option to enable your concurrency scaling. So I just clicked on edit workload queue. After clicking on edit workload queues, you can see your page will came to here. So here you can see concurrency scaling mode. For that parameter group, whatever the parameter group you have Redshift PG that we created, for that we are modifying or editing a workload queue that is concurrency scaling mode. So just click on it so that you have two options, that is off mode as well as auto mode. There is no on mode. If you provide concurrency scaling mode as auto, then you can assume it as the on mode. We just on the concurrency scaling mode. Now under the concurrency scaling mode, you just set up it to auto mode and then click on save. So what you need to do, set it to auto mode and click on save. Now what happens is, so you have just set up your parameter group and you enabled concurrency scaling. You enabled concurrency scaling. Now, how you enabled? By using auto mode. Which mode? Auto mode. Not no on option is available, only auto mode. So here you can see for your reference, I have even written set this concurrency scaling to auto mode. So now after setting, your parameter group now enabled with whatever the concurrency scaling. Now you need to provide, right, whatever the max concurrency scaling clusters, how many total number of max scaling concurrent clusters, that option you need to tell, right? So let's see how to provide it. Here you can see under your parameter group, a parameters option is there. So from these parameters, you can able to set the parameter, that is max number of clusters for your concurrency scaling, that you can able to set from these parameters. So just click on these parameters. So let's say I clicked on it. You can see an option, that is max concurrency scaling clusters. Max concurrency scaling clusters. Currently it is 1. I want to edit it. So click on edit parameters. Let's say I clicked here. Since I want to modify this in between 0 to 10, I'd like to provide some random number, that is 5. So up to 5 clusters I want to provide. So I typed here 5, and then now I click on save, so that my parameter group is saved. Till now, we created a parameter group and we enabled our concurrency scaling by setting this concurrency scaling to auto mode, and we provided this max concurrency scaling clusters by using the properties tab of my parameter group. Now at last, what is the thing left? I want to attach this parameter group to what? My Redshift cluster, right? So let's see how to do this. You can see under dashboard of your Redshift clusters option. Under this, if you click it, then you have an option called clusters. So just again click here, so that whatever the clusters you have, those will be visible to you. Here you can see what are the available clusters that you have created. So here I have already created, that is this Redshift cluster for us. So just click on it so that it will open for us. Now I opened whatever the cluster that I was shown. So you can see Redshift cluster 1. So here at first it will be present here. Now I clicked here so that it will come under properties tab. So you can see here database configurations. Yes. So what is the parameter group assigned to it? It contains some default Redshift 1.0, that parameter group. Now what I want to do? Now I am expecting to attach whatever the parameter group that I have just created. So that you just click on this edit option. Then you can see 3 options, that is edit parameter group, edit audit logs, edit encryption. Now I want to edit parameter group, right? So now I click on this edit parameter group. After clicking this, I will be redirected to here. A pop-up will be appeared like this. So here you need to specify whatever the group that you want to provide. So previously it has a default group. I just provided this as a Redshift PG, whatever the group that I have just created. So then just click on save. So that everything is set up was done. That's it, guys. We can now just enable our concurrency scaling to our Redshift cluster. So how we enabled? We just created a parameter group with some name and description. And then what we did? We just opened that parameter group. Under that, we just gone for concurrency scaling, where that concurrency scaling was available for us under edit workload queues. So under the edit workload queues parameter, we just gone for this concurrency scale. Then we set this concurrency scaling to which mode? Auto mode, so that it will be on. Now, what we did, our concurrency scaling was on, then we need to provide the max concurrency scaling clusters, right? So for that, we opened the parameter group. Then what we did, so in that we opened the parameters, there we edited max concurrency scaling clusters that we provided for. Under this example we provided 5. So like this we provided the max concurrency scaling clusters as 5 only. Then we finally attached that to our Redshift cluster. That's it. Our Redshift cluster is now attached with enabled concurrency scaling by using what? Parameter group. So by default, what this Redshift cluster is attached with? A default parameter group. So in order to attach this concurrent scaling, first create another parameter group with what are the required configurations that you want, max number of cluster scaling, max number of concurrent scaling clusters you want, that you need to provide. and enable this concurrent scaling, and then just attach it to your Redshift cluster. That's it. Under concurrency scaling, it will give you Redshift cluster. That is, it will boost, but it is not substitute of your good table and solid query creation. For solid query creation or for good table design, what you want, you need to go for this concurrent scaling cluster. You need to go for this cluster resize. Either it may be classic or elastic. So when do we use this? Whenever you're having a need of high demand of traffic, then you use this cluster. Which type of cluster? Which type of scaling? This is concurrency scaling. Then you need to use this concurrency scaling. Concurrency scaling cluster. Not every queues need to access a concurrency scaling cluster. Concurrency scaling cluster is best for giving high priority queues. The equivalent of, like, you can even assume it like express bus on your highway. So like that, whatever the high priority queues that you have, those you can able to send this to concurrency clusters. So based on your need, you can able to send this. So this is all about concurrency cluster, concurrency scaling. I hope you understood this concurrency scaling and you got some knowledge on this video and how to implement this concurrent scaling via console. I hope this video is understanding to you. If you feel this video is understanding, then please like, share, subscribe, and hit the bell icon to get the latest updates. See you back in the next video. Until then, bye bye guys. Thanks for watching. See you back. If you like the video, then please like, share, subscribe, and hit the bell icon to get the latest updates. See you back in the next video. Until then, bye bye guys. Thanks for watching.